Hi class, today we're going to be talking about lesson 1-4, graphing relationships. Our objectives for today are we can match simple graphs with situations and we can graph a relationship. Alright, let's look at our first example, relating graphs to situations. The air temperature was constant for several hours at the beginning of the day and then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. We need to choose the graph that best represents the situation. Is it graph A, graph B, or graph C? Well, our first step in this problem is to read the graphs from left to right and that show time passing. So from left to right, we have on graph A, as time passes, we stay fairly steady, and then we go up until we get to a peak, where then we start to decrease again and stay steady. For graph B, we have a steady beginning where we rise, and then we are steady, and then we drop sharply. In the graph C, we rise, we are steady, and then we rise again to a peak where we then go down. So let's look at step 2. We need to list the keywords in order and decide which graph shows them all. Well, let's read the question one more time. The air temperature was constant. So that is important to notice. If our air temperature was constant, that's a horizontal thing on the graph, which we see right here in graph A and right here in graph B. But we don't see a constant start in graph C. Then it started to rise steadily for several hours. Well, I see that again in both graphs A and in graph B. After it rose steadily for several hours, we stayed the same temperature. I don't see that in graph A because it has that peak and then it drops again. But in graph B, we have this steady line going in there. Now we drop sharply. I also see that happening in graph B, right here. So that means for step 3, we can now determine which is the correct graph. Because it was horizontal where it was constant, it was going up when it rose steadily. It was horizontal when we stayed the same, and then it went down. There was only one graph that showed all 4 of those situations, graph B. So our correct graph is graph B. Alright, vocabulary alert time. We've got 2 different types of graphs we're going to talk about in a second. We have continuous graphs, which are just graphs of connected lines or curves. An example of this you might encounter in your real lives are if you go to the grocery store and buy, for example, grapes. You can have fractions of a pound of grapes when you check out at the counter. If we wanted to graph all the prices that grapes could have at the grocery store, we would have a continuous graph because you can have fractional amounts of the weight and fractional amounts of the price. Discrete graphs are just graphs of distinct points. An example of this might be if you go to the store to buy some CDs or some DVDs, you can only buy those in whole number values. You can't get half of a CD or half of a DVD. You have to buy a whole 1 or a whole 2 or more. No halves, no fractions at all. So on one of the axes, you have to go by whole number parts. You can't connect the dots. That would be an example of a discrete graph. Alright, let's look at our second example, sketching graphs for situations. We have to sketch a graph for each of the situations and tell whether the graph is continuous or discrete. So example A. Simon is selling candles to raise money for the school dance. For each candle he sells, the school gets $2.50. He has 10 candles that he can sell. So let's start by first drawing a graph we can use to graph the situation. Alright, so there are a couple important things that this graph needs. One of those is a title. We are talking about how much Simon can earn. So our title would be Simon's earnings. One of our axes needs to represent the amount of candles that Simon sells. So the candles sold. We know he has up to 10 candles he is able to sell, so we'll just go up to 10. Then there's the amount that he earns for that many candles he sells. Let's just go that every other mark is 5, since each candle that he can sell is worth $2.50. So every mark is $2.50. Now let's graph. He could sell 0 candles. If that's the case, he would make $0. He could also sell 1 candle. If that were the case, he could make $2.50. So we would put a mark at 1 and $2.50. If he sells 2 candles, he could make $5. So we'll put a mark at 2 and 5. If he sells 3 candles, he could make $7.50. If he sells 4 candles, he could make $10. 5 candles, $12.50. 6 candles, $15. 7 candles, $17.50. 8 candles, he could make $20. 9 candles, he could make $22.50. And at 10 candles, he could make $25. Now the question we need to ask ourselves is, can Simon sell half of a candle? Well, unless he's going to actually physically cut a candle in half, which I don't think a customer of his would be happy about, he can't sell half of a candle. So we're not going to connect the points, which means that this graph is discrete. Now let's look at another example where we need to sketch the graph. We have Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate rises at a steady rate. When she begins to run, her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to her normal rate. So let's make a graph so we can graph the situation. Alright, we do need to label this and title it. So on our x-axis, our axis that moves from left to right, have time. On our y-axis, the one that moves up and down, we have the heart rate, and we have titled this Angelique's heart rate. So let's think about this situation. As she is walking on the treadmill, her heart rate remains pretty steady, pretty much the same. Then she starts to increase her pace, which means that it rises at a steady rate. Then she starts to run, which means that this is a more rapid increase. Now she's still running, so her heart rate is going to remain the same. It's going to stay high, but stay there because our heart can only go so fast. Now she starts to decrease. She's in her cool down phase, so her heart is going to start to slow down until she gets to her normal resting heart rate. So let's graph this. Let's think of those situations and graph it. If our heart rate, or Angelique's heart rate, starts off somewhere and it remains the same, it's just going to be a steady straight line. Then if it starts to rise a little bit, but not too much, we're going to start increasing the heart rate as time moves along. Now she's going to start running. That heart rate is going to increase even more rapidly. So we need to increase how much that is rising. Now she is running. Her heart can only go so fast, which means it now goes constant once it gets to that maximum heart rate. Now she's going to enter her cool down phase. So that heart rate is going to start to decrease, start to slow down. After that's happened, her heart has to get to a minimum rate. It's not going to decrease anymore, so it's going to steady off and remain constant for the rest of the time. Now, when we look at this, the heart rate can have times and beats that are within fractions of a second. So we do connect points and everything in this graph. So when we look at this graph, this is a continuous graph. Alright, now let's look at our last type of example, where we write situations for graphs. We need to write a possible situation for the given graph. Our first step is to identify the labels. On our x-axis, we're representing time, and on the y-axis, we're representing the water level. Our next step is to analyze the sections. What is going on in the graph? So over time, what does the water level do? Well, here in the red, the water level is increasing steadily. Then, in the blue, we do not see any change in the water level at all. And in the green, we see a steady decrease. So, a possible situation, but not the only thing that could work for this, a possible situation that could be said for this graph is that a watering can is filled with water and it sits for a while until the flowers are planted. Then the water in the can is emptied on top of the planted flowers until the watering can is empty. So we have finished lesson 4.1. What I would like you to do for the rest of the night is to do the your turn problems on your notes for class tomorrow. Have a good evening.